Before we graph anything, take a look at the equation y equals 2x minus 3. This equation has two variables, x and y is expressed in terms of x. Now if x equals 2, then what does y equal? And click down here to review equations with two variables. Right, when x equals 2, y equals 1. So let's come up with a graph for this equation. Try plotting the point whose x-coordinate is 2 and whose y-coordinate is 1, and click over here if you'd like to review coordinates. Nicely done! So this point, 2, 1, is part of the graph for this equation. When x equals 2, y equals 1. Let's try plotting another point. For this equation, when x equals 3, what does y equal? Exactly. When x equals 3, y also equals 3. So 3, 3 is another point in the graph for this equation. Go ahead and plot 3, 3. Okay, so far you plotted 2 points for this equation, 2, 1 and 3, 3. Next, try plotting the point whose x-coordinate is 1. So first, you'll want to use the equation to figure out what y equals when x equals 1, and then you should plot the point. Great! So now we have 3 points for the equation with x-coordinates of 1, 2, and 3. What about when x equals 0? Plot the point whose x-coordinate is 0. Nicely done! So 0, negative 3 is also part of the graph for this equation. And what about negative values of x? Plot the point whose x-coordinate is negative 1. Right, when x equals negative 1, y equals negative 5. You might notice that our graph for this equation is forming a pattern. But let's plot one more point. So far, we've been looking at whole number values for x. But what if x is not a whole number, like 2.5? Plot the xy solution for this equation whose x-coordinate is 2.5. Exactly. When x equals 2.5, y equals 2. So what's the pattern formed by the solutions to the equation y equals 2x minus 3? Do these points form a circle, a curve, a straight line, or a square? Excellent! So for the equation y equals 2x minus 3, here are a few solutions that you plotted on the coordinate plane. And these aren't the only solutions. You can plug any value of x into this equation and get a value for y. So if you were to plot all the solutions to this equation with all the whole numbers and decimal values for x, you get this straight line. These arrows on either end mean this line goes on forever in both directions. So this line is the graph for the equation y equals 2x minus 3. So nicely done. Let's look at one more equation. Y equals negative x plus 4. For these values of x, find the corresponding values of y that solve this equation. And here's the graph of those x and y values you just found. It looks like the graph for this equation is also a line. Go ahead and plot another point on the graph for this equation. Pick any value for x, solve for y, and plot the coordinates you get. Great! So for the equation y equals negative x plus 4, here are a few of the points on the graph. And if we were to plot all of the solutions, we'd get this line here. In general, for any equation that takes this form, y equals some number times x plus another number, the graph will always be a straight line. And the values for these two numbers, whether they're positive, negative, or 0, determine the position and orientation of the line. In later lessons, you'll be able to look at an equation like this and immediately draw its corresponding line. To get started, here are a few points on the coordinate plane. Which of these points are solutions to the equation y equals 2x plus 3? And click down here if you'd like to review graphing solutions to equations like this. Exactly. These 4 points are all solutions to this equation. For example, this point is 1, 5. It's a solution because when you plug in 1 for x in this equation, y equals 5. Now, if you were to plot all the solutions, they would form this line here. Now, the y-coordinate, where a line crosses the y-axis, is known as the y-intercept. So what's the y-intercept for this line? What's the y-coordinate of this point over here? Exactly, this line has a y-intercept of 3. And notice that we have a 3 over here in the equation. Very interesting. Let's see if we can figure out why that might be. Well, the y-intercept is the point where a line crosses the y-axis. And for every point on the y-axis, the x-coordinate is 0. All the points out here have positive x-coordinates, and all the points out here have negative x-coordinates. But the x-coordinates along the y-axis are 0. So at the y-intercept, x equals 0. So then what's the y-coordinate at the y-intercept? Well, we can plug in 0 for x to find the corresponding value of y. 2 times 0 is 0, so that leaves us with y equals 3. So sure enough, 3 is the y-intercept of our line. Try another example. For the line described by the equation y equals 3x minus 4, what do you think is the y-intercept? Excellent! The intercept is negative 4, because if you plug in 0 for x, that leaves you with y equals negative 4. And here's the actual line for the equation. It also passes through 1, negative 1, 2, 2, and 3, 5. Next, go ahead and calculate the slope of this line, or click down here if you'd like to review. Right, so this line has a slope of 3. And that's the coefficient of the x term, meaning it's the number you multiply by x. Again, that's very interesting. Let's try another example. Of these points here, which are solutions to the equation y equals 1/2 x plus 1? Right, these 3 points are solutions. And here's the line for the equation. Sure enough, it has a y-intercept of 1, which is this number over here. But what's the slope of this line? Precisely, the slope of this line is 1/2, which again equals the coefficient of the x term. So what's going on here? Well, suppose x equals 0. Then according to this equation, y equals 1. So that's this point on the line over here. Now let's say x equals 1. What does y equal? Well, by increasing x from 0 to 1, we've added exactly 1/2 to this side of the equation. So that means y now equals 1 plus 1/2. Over on the graph, we increased x by 1, and that means y increased by 1/2. Let's try that again. If we increase x by 1, then x now equals 2. So we've added another half to this side of the equation, which means y now equals 1 plus 2 halves. On the graph, we've increased x by 1, and again, y goes up by a half. So whenever we increase x by 1, y increases by 1/2. So then 1/2 must be the slope of this line. For any change you make in x, the change in y will always be 1/2 of that. So a general way to write equations for lines is like this. Y equals mx plus b. M is the coefficient for x, and it will always be the slope of the line. And as you saw earlier, this number that you're adding over here, b, is the y-intercept. Equations that are written this way, y equals a number times x plus or minus another number, are said to be in slope-intercept form, because by looking at the equation, you can quickly read off the slope and the y-intercept of the line. For example, for the line y equals 7x minus 15, what are the slope and y-intercept? Okay, so at this point, you'll be the one who draws the lines. You can drag the green line to change its slope, which is displayed up here, and you can drag the yellow dot up and down to change the y-intercept. Here's your first challenge. Draw the line for the equation y equals 2x plus 3. So try figuring out the slope and y-intercept from the equation, draw the line, and then press the Submit button over here. Excellent! So here's the line y equals 2x plus 3. Its y-intercept is 3 and it has a slope of 2. Here's your next challenge. Try drawing the graph for this equation, y equals negative 3x. Notice that you're not adding or subtracting anything after the x term, so you can think of this as negative 3x plus 0. Perfect. So here's the line y equals negative 3x. It has a slope of negative 3 and its y-intercept is 0. So this line passes through the origin, which is the point 0, 0. Next, try drawing the line y equals x over 2 minus 4. To find the slope of this line, think of an equivalent way for writing x over 2. If you get stuck, feel free to ask for a hint. Exactly. So here's the line y equals x over 2 minus 4. It's the same exact thing as y equals 1/2 times x minus 4. So the slope is 1/2, or 0.5, and the y-intercept is negative 4. Next, draw the line for y equals negative x plus 5/2. Again, think carefully about what the slope of this line must be. Great, so here's the line for y equals negative x plus 5/2. The y-intercept is 5/2, or 2.5, and the slope is negative 1, because negative x is the same thing as negative 1 times x. Next, try drawing the line for y equals negative 2. This time, there's no x term at all, so can you figure out what this line looks like? Again, feel free to ask for a hint if you need one. Precisely, so this is the line for y equals negative 2. You can think of this as y equals 0 times x minus 2. So the slope is 0 and the y-intercept is negative 2. You can also just think of this as y equals negative 2. So for every value of x, y always equals negative 2. Either way of thinking about it, you get the same line. Okay, so the next two questions are a little different. Now you're being asked to draw the line for the equation 3x plus 2y equals 4. This equation is not in slope-intercept form, which is y equals mx plus b. So the challenge here is to first solve this equation for y in terms of x, so that you can read off the slope and y-intercept. So give this a shot and feel free to ask for a hint. Excellent! 3x plus 2y equals 4 is the same thing as y equals negative 3/2 x plus 2. Alright, here's the last one of these. Try graphing the equation 3y minus 2x plus 3 equals 2y minus x. Again, you'll first want to write this in slope-intercept form. Okay, let's finish this lesson by working backwards. So here's a line that passes through the points 0, negative 2 and 2, 1. What's the equation for this line in slope-intercept form? So what's y in terms of x? Nicely done. The slope is 3/2, so we have a 3/2 x term, and the y-intercept is negative 2, so y equals 3/2 x minus 2. Alright, last one. This line passes through negative 2, 4 and 2, 3. What's the equation for this line? Notice that you're not given the y-intercept here, but perhaps you can figure it out. If you get stuck, click down here.